Have you ever wondered why, despite, sending rovers to Mars, mapping the entire human genome, and literally splitting the atom, we still can't scientifically explain what a thought actually is? Welcome to this explainer. Today, we're unpacking a genuinely fascinating paper by independent researcher John Canelo called Explanatory Horizons. We're going to dive deep into the architecture of human inquiry, the absolute boundaries of scientific explanation, and this highly provocative idea. What actually happens when science, despite all its incredible compounding progress, just hits a wall? It's a deep dive into how we seek truth and why some mysteries stubbornly resist being solved no matter how much data we throw at them. Right, let's just jump straight into this with the ultimate mystery. Why does it actually feel like something to be alive? Seriously, take a second and think about it. Why do you have this rich, internal, subjective experience of a vibrant sunset, instead of just the cold, mechanical processing of light waves hitting a retina? I mean, we've got cameras that process light waves, right? But they definitely don't experience the sunset. This right here is what philosophers famously call the hard problem of consciousness, and it's our gateway today into understanding the very limits of human knowledge. To get why this is such a brain bender, we really have to look at how consciousness research gets divided up. On one side, you have the easy problem. And hey, easy is definitely relative here. This is all about mapping the biological mechanics of the brain. Understanding memory, attention, predictive processing, how the brain actually makes information accessible to us. And science is crushing it here. We can literally watch a brain light up in an MRI when someone thinks about eating a taco. But then there's the hard problem, explaining why that experiential presence exists in the first place. We can map the biological mechanics perfectly, but that totally fails to explain why experiencing reality actually feels like anything at all. Section 1. The mystery of consciousness. So, this persistent friction, where we nail the underlying mechanics, but remain entirely, fundamentally baffled by the existence of the experience itself, that's our starting point. It forces us to look closer at our tools and ask, are we even using the right ones for the job? Section 2. 4 modes of inquiry. If we want to figure out why some questions seem absolutely impossible to solve, we first need to break down the 4 distinct ways we humans actually search for truth. Let's walk through this architecture. Mode number 1 is phenomenological inquiry. This deals directly with what you feel and experience in the first person. It's not about the physical cause. It's about the pure structure of the lived experience. When you stub your toe or you see the bright red of a stop sign, the phenomenological mode investigates that raw, undeniable occurrence entirely from your point of view. It's the what it is like of reality. Next up, we have empirical inquiry. This is the traditional engine of modern science. It's all about data, observation, rigorous measurement, and uncovering hidden mechanisms that anyone can publicly verify. So if you want to map the exact neural pathway firing when you stub that toe, or measure the exact wavelength of the red light, you're firmly in the empirical mode. It's absolutely our best tool for figuring out how the physical universe behaves. Then there's ontological inquiry. This mode takes a massive step back. It seeks to integrate everything to figure out what fundamentally exists. It asks the deepest questions possible. Think of it like looking at the underlying code of the matrix. Is consciousness just a glitch in our biological hardware? Is it an emergent property? Or is it woven directly into the fabric of the universe itself? Ontology is all about interpreting the ultimate nature of things. Finally, epistemological inquiry. This is the deeply reflexive mode. It asks, how do we actually know what we know? It examines our evidence, questions what justifies our beliefs, and evaluates our methods. It's basically the ultimate referee of science, setting the strict rules for what counts as a legitimate explanation across the other 3 modes. And Cantello proposes this brilliant network model of inquiry, showing how these 4 modes definitely don't operate in a vacuum. They mutually inform and constrain one another within a much broader metaphysical space. They're totally interconnected. Phenomenological observations motivate new empirical tests. That empirical data then constrains our ontological interpretations, and epistemology sits right there governing the whole shebang. It's a dynamic, interconnected toolkit. Section 3. The problem of evidence. Now, let's see how this specific architecture might actually construct the perfect, inescapable trap for scientific progress. It all comes down to how these modes connect. To really grasp this, we need to talk about evidential traction. Think of this as the grip our tools have on a given problem. It's the capacity of our methods to constrain, discriminate among, or progressively narrow down competing interpretations to find the absolute truth.
When evidential traction is high, gathering more data quickly eliminates the wrong answers until only the right one is left standing.
But here's the catch. Not all connections in our network are equally strong. The link between phenomenological inquiry, which describes an experience, and ontological inquiry, which interprets fundamental reality, is inherently super weak. You can describe the feeling of consciousness perfectly in beautiful poetic detail, but that description simply doesn't tell you what consciousness fundamentally is in the grand scheme of the universe.
So why does this weak link matter? Well, the problem is this massive gap between descriptive modes and interpretive modes. Descriptive modes are incredible at observing what's given to us. Interpretive modes try to explain what ultimately exists beneath it all. Because the bridge between what we feel and what fundamentally exists is so weakly coupled, multiple, totally contradictory philosophical frameworks can easily, flawlessly fit the exact same set of facts. And this creates what's formally called persistent underdetermination. It's incredibly frustrating. You can gather massive amounts of new empirical data, build incredible new tools, uncover complex mechanisms, and yet it literally doesn't help you choose the correct interpretive answer. The facts just keep piling up into mountains of data, but the core mystery stays perfectly intact. It's like having a locked safe and suddenly realizing you have several completely different keys that all seem to magically turn the lock.
Section 4. Reaching Explanatory Horizons. This brings us right to the core thesis of Cantelau's paper. What actually happens when the grand pursuit of science hits this wall of underdetermination head-on?
We reach an explanatory horizon. Now, let's be clear, this isn't some magical barrier or a declaration that something is permanently unknowable. Instead, it's a specific region of inquiry where the relationship between making scientific progress and finding the right answer starts to break down. You keep mapping mechanisms, you keep getting vastly better data, but you experience what's called diminishing discriminative leverage. In plain English, the new data simply doesn't help you choose between the remaining interpretations anymore.
To prove this isn't just some weird quirk about human brains and consciousness, let's look at cosmology. We've had brilliant, undeniable empirical success mapping the universe, right? We can track the cosmic microwave background, we know how galaxies cluster, we understand the accelerating expansion of the universe. Absolute triumph of science. But we hit an ontological horizon when we step back and ask the big one. Why is there a universe with these specific mathematical rules instead of just nothing? Why do the laws of physics exist in this exact form? A telescope can show you a brilliantly burning star, but it has zero evidential traction on why the laws of physics actually allow that star to exist in the first place.
Section 5. Rethinking scientific limits. So, how should we react when our pursuit of knowledge inevitably hits one of these explanatory horizons? Does this mean science has ultimately failed us? Absolutely not. Let's look at how we need to rethink these limits. First, we need to know how to spot them in the wild. It's basically a checklist. Are we seeing continued progress, like mapping thousands of new neural pathways without gaining any ground on the hard problem? Check. Is the mystery totally stable despite massive new evidence? Check. Do we see a clear decoupling between gathering facts and solving the core issue, leaving us with multiple coherent frameworks where no single winner can be definitively chosen? Check. When we see these indicators, we know for sure we're at a horizon. As Cantelau highlights, hitting a horizon isn't a failure. It's a fundamental feature of human inquiry that requires some deep methodological humility. It shows us that our scientific tools are wondrously powerful for certain types of questions, but that technological progress and ultimate philosophical explanation don't always move in a straight parallel line. We absolutely shouldn't abandon our empirical investigations, but we desperately need to recognize when simply gathering more data isn't doing the job we think it's doing. Which leaves us with a profound final thought. If an explanatory horizon isn't a failure of the universe to be understood, but rather a perfect reflection of the very architecture of how humans ask questions, what else lies just beyond the limits of our evidential traction? When endless data is no longer enough to lead us to the absolute truth, how will we boldly adapt our search for meaning? It's a question that challenges the very foundation of how we seek to understand reality. Thanks for joining me for this explainer.